said, like the Binet can do a broadcast, multicast, and even point-to-point communication between the Ps and the AMP. Also, this Binet is responsible for merging the answer set. Like each AMP retrieves the data, right? So it will pass through the Binet, and Binet is the one which merge the answer set, and the final one will be passed to the P and then to the user. So this is how the parallel processing is achieved in Teradata. Like if each AMP directly passes the data to the P, and it will be a overhead to the P, right? To again consolidate everything. One second, Priya sent a message.
1 minute, yeah.
We record the session. I think it's getting recorded, right? Yeah.
Yeah.
Okay. Yeah. So, right. So this Binet, it helps like it helps in most of the case where the result set has to be merged and then it will pass to the P. And it is also used for automatic load balancing, in the sense like suppose in some cases when a Binet is over occupied with traffic, so the secondary Binet, it will automatically come in and it will take the load and it will pass some messages. So the load balancing is also done from the Binet point of view. And whenever these nodes are added, right? So even the bandwidth of this Binet, it can be increased to accommodate the node changes. So when you move from 50 nodes to 100 nodes, right? Then usually it will be 10 or 4 nodes at the time they will add. And in that case, if Binet is less in size, then it will be a it will be a performance issue, right? So even you can increase the Binet with more GBs in that case.
Okay, Binet is something like a cable or the bus, everything including, or how exactly?
The hardware kind of Binet is exactly like a bus.
Okay.
So it has a separate power supply and those kind of things.
Okay. Have you got a chance to visit to a data center of Teradata? Any chance?
Yeah, I visited once when I was there in Mumbai.
Okay.
Mumbai, we have one data center.
Okay. And see, the whole system they are keep because whenever they have a requirement to get adding a space, they will get a node, right? In say in terms of what they're saying, like if they are falling short of space, or they want to go for more CPU kind of thing, the system is not performing, they will go for a buying new node, correct? So in that case, how exactly these guys are doing that activity? Simply they are joining with the cable with the current system and matching it this one, or completely in the hardware level they will put some socket or something like a RAM socket we have in our laptop or PC, so just like that, one slot will be there, we'll just place it. How exactly they will do this kind of things?
So this expansion, right? Like it's not like hard swappable. So what they will do, they will buy new physical node itself, like, and they will join to the existing nodes and the existing Binet.
Okay.
And then what they will do, they will do the rebalancing, right? So whatever data is stored here, it has to be passed to the new nodes also, and it will be
Okay.
balance.
Okay. So if new node has added means the data will get redistributed, correct?
Correct. Yeah, it will be redistributed.
Because say for you are having some 100 amp system,
Mhm.
you are buying a new node that is having 10 amp. I'm giving an example. Okay.
Right, right.
10 amp means that will become 110 amp system, no? So all data has to distribute among the 110 amps, no? Now it is 100.
Correct, correct.
uh,
So usually
okay.
they take a downtime of 24 to 48 hours. So in
Okay.
this time frame, right, they will do these
Okay.
balancing, those kind of things.
Okay. Okay. Node is we can think like I don't know, might be the size now that has reduced, kind of a CPU box or something.
Uh,
uh,
yes, it will be around 7 to 8 feet high,
mhm.
and then it has all these components, racks, everything inside that.
Okay. 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 If they want, if they are purchasing new node means the same kind of a box they are
Yes,
keeping aside.
correct. Yes, yes.
Okay. 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 Yeah, because just to imagine how exactly
Yeah,
uh,
right.
it is. Yeah,
Usually
we just
we don't get a chance until we have access to the DC. Usually DBS never go to the DC, right? But on some
correct. Correct.
exception cases, we used to get. And
Okay. Okay.
most of the cases with the clients is most of the clients, even we have clients in India, but usually it's from US or Europe, right? So
Yeah. Yeah. Correct.
DC will stay over.
They are having the data center
Right,
in their location. Yeah.
right. Yeah.
Mhm.
Oh, that's the case.
Okay. Okay. Yeah. Thanks.
Okay. So, and this is the example of data layout, like how the table which we have are distributed among the amps. So in this case, we are having a example of 4 amps. So each table will be stored in uh, each amp like a drawer, right? So employee table, no, it will be distributed among all the amps. So it will have each amp will have whatever data which is assigned to this amp. So we'll see like how this data is getting distributed among the amps in future sessions. So this is just an example to imagine like how the data is getting stored in the amp, basically into the drive, but through the amp. Okay.
Okay. Okay.
So this is another example like how no the records, uh, the columns are stored into the AMP and how the parallel processing is done, right? So suppose consider this is a table with employee details, right? So first 3 records are stored into first AMP, and similarly it's distributed among them. So whenever we do a select star, what will happen? All the amps will run individually, and it will share as the result at a time, right? So it's not like dependent on these amps to complete the operation. So all the amps at a time it will run, and it will share which flows, like the P checks the user SQL syntax, the P check the user security rights, right? So first step, like if you have a column missing or something is wrong with the SQL, it will throw the error, the first step. And the second one is right, you have the right to access the object which you're trying to access, right? So suppose you have a table and for which you don't have access. So in that case, in that case, you will get an error, right? So user does not have access on this table. So that is done from the
Okay.
so
Okay.
syntax and semantic checks. Yeah. And then the plan comes and the plan is passed to the amps or the binary, and then and the plan the AMPs follows the plan and then retrieve the data and pass to the PE as we discussed. Right? So you were talking about this row hashing, right? So this is just an example of how this row hashing is done. Okay, so suppose we have a table, employee table with this PA value, right? So I think this comes in the third and fourth chapter, right? So as you were asking, I'm just explaining here. So
Yeah, I know this. There is a hashing algorithm.
right,
It will pass that primary index value to that hashing algorithm.
right,
It will generate this unique this number.
correct,
According to that, it will search in a hash map that will say like
yeah,
which AMP that row should go.
correct, yeah, the hash bucket actually. So yeah,
Hash
so this is the
hash map.
hash map, and
Okay.
so this whole thing is called as a bucket, and in that we have a
Okay.
map. Yeah. Yeah. So yeah, as you know about this algorithm, whatever value means how much time you pass the same value, the result will be the same. The hash formula will give you the same result. Right?